Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Hafizuddin bin Muhammad Rosli. Today I will present about my FYP1 project, that is development of recycled polypropylene fly ash sugarcane bagasse fiber for decking application. For the project summary, the waste plastic and fly ash have caused many environmental problems such as water pollution, air pollution, and flash flood. There is no chemical bonding between recycled polypropylene and fly ash particle in the recycled polypropylene and fly ash composite. Then, the flexural strength of the composite also reduced when the amount of fly ash increased. So, we introduced sugarcane bagasse fiber and polypropylene grafted malate anhydride as a coupling agent in recycled polypropylene fly ash composite to create the chemical bonding between particles and flexural strength. There are 5 variation composition of the recycled polypropylene fly ash and sugarcane bagasse fiber. There is 60 to 30 to 10, 60, 20, 20, 60, 10, 30, and 65 and 35. Rheology tests will be conducted to determine the melting temperature, viscosity, and the flow behavior of material. Polypropylene grafted malate anhydride will fuse at 5% at all 5 specimens. All the material will be dry, crushed, and treated before packed into a twin extruder machine. The product will be transferred to the hard compression molding to shape the specimen. All the sample will be used for morphology structure, tensile, flexural, and hardness tests. The problem statement of this project is the tensile strength of the polypropylene and fly ash composite used when the fly ash composition increased because of the absence of chemical bonding. Next, based on the SEM, there is poor adhesion between fly ash particle and polypropylene particle, and the fly ash particle do not bond with the polypropylene matrix that leads to fracture. The lack of interfacial adhesion between recycled polypropylene particle and fly ash also contribute to the loss of strength. And lastly, the flexural strength of the recycled polypropylene and fly ash decrease when the fly ash composition increases. The objective of this project is to determine the rheology properties and morphological structure of recycled polypropylene, fly ash, and bagasse fiber composite. To determine the tensile, flexural, hardness, and properties of recycled polypropylene, fly ash, and bagasse fiber composite. The scope and limitation. 5 specimens with different composition of recycled polypropylene, fly ash, and sugarcane bagasse fiber ratio will be tested. The polypropylene grafted malate anhydride used is 5% per sample. The recycled polypropylene is collected from Zhu Chi Recycling Center at Kelang, Selangor, and only food container such as Tupperware and ice cream container used to fabricate this project. The Type F fly ash was collected from the Salahuddin Abdul Aziz Shah station at Kampung Selangor. Sugarcane waste will be collected from sugarcane juice sellers at Section 7, Shah Alam, Selangor, and will be grind using a disintegrator machine for 5 minutes. The grinded sugarcane will be sieved to size 60 mesh and undergo splitting with 3% sodium hydroxide solution. Rheology tests will be conducted using modular compactor at temperature 180 degrees Celsius. Diameter 25 mm and gap distance 1. The recycled polypropylene, fly ash, sugarcane bagasse fiber, and polypropylene grafted malate anhydride will mixed by using twin screw extruder. The product of extrusion will be transferred to the hard compression molding. The standard tensile test will be conducted. The flexural strength will be determined by the flexural test, and the hardness test and surface is measured by standard electron microscope. So I will explain about literature review. The third material needs to be determined to find suitable material that can solve the problem. Based on the comparison, the combination of polypropylene, fly ash, and natural fiber has shown the highest value strength, which is 56 megapascal. The addition of natural fiber has increased the mechanical capacity. It can be shown when the quinoa fiber and pineapple fiber treat with sodium hydroxide that increase the tensile strength of the composite. The composite between recycled polypropylene and monocrystalline fiber also show an increment of tensile strength. The comparison between the natural fiber reinforced polypropylene has shown that the sugarcane bagasse fiber has the highest flexural strength value, which are 52 megapascal. Next, the alkali treatment is a popular method to modify and clean the natural fiber surface to enhance interfacial bonding. Based on the record, 5% sodium hydroxide have improved the tensile strength and Young modulus by 8% and 35% respectively. Coupling agents are defined as chemical substrates that improve the adhesion between two or more materials in composite. The polypropylene grafted anhydride present as a agent has improved the adhesion between the materials. The table below shows the list of coupling agents in it and fly ash. For the material preparation, the polypropylene waste will be collected from the Zuchi Recycling Center at Kelas Selangor. Then, fly ash we collect from Salahuddin Abdul Aziz Shah Power Station at Kapar, Selangor. Sugarcane bagasse fiber will be collected from sugarcane juice seller at Section 7 Shah Alam. The sodium hydroxide and malate anhydride will be prepared. The material will be cleaned, dry, crushed, and sieved. For the pre-treatment, the sugarcane bagasse fiber will be treated with 3% sodium hydroxide solution. Then it will be rinsed and dried. Before the extrusion process, rheology tests will be conducted to know the viscosity and the flow behavior of the material. For extrusion process, the twin screw extruder will be used, and parameter set is screw diameter 15.6 mm at speed 60 rpm and temperature 190 degrees Celsius to 200 degrees Celsius. Then the product of extrusion process will be transferred to the compression molding machine for compression process at temperature 200 degrees Celsius, duration 5 minutes, and mold size 150 mm times 150 mm times 3. Then the specimen will be undergoes the mechanical measurement, that is tensile test, flexural test, and hardness test. And for physical measurement, it will be used scanning electron microscope. All the data will be collected for data analysis and the process end. For the test performed, the standard tensile test will be conducted according to STM D63X. Measure the The flexural strength of the composite will be determined by using static 3-point flexural test according to ASTM D79010. The hardness test will also be conducted using standard ASTM D7X. The surface and cross-section fiber will be observed by using scanning electron microscope. For the expected result, the bonding between recycled PP, fly ash, and sugarcane bagasse fiber particle should be formed by the adding PP grafted malate anhydride. The main structure of sugarcane bagasse fiber is cellulose, hemicellulose, and lignin. So, at the surface of cellulose, it has the hydroxy group that when react with polypropylene grafted malonhydrate, it will experience the esterification that will form the hydrogen bridge between cellulose surface and polypropylene grafted malonhydrate. The hydroxyl group on the silica surface at the fly ash can help the interface interaction between fly ash and poly. The high malonhydrate concentration will improve the interaction between PP and fly ash particles. The hydroxy group at the surface of fly ash will react with malonhydrate through esterification process that will create hydrogen bond between polypropylene grafted malonhydrate and fly ash. It is expected that all the material will be bond by the addition of coupling agent, polypropylene grafted malonhydrate, and the mechanical properties of the composite will be. This is the project plan of my project. There is the reference. That's all from me. Thank you.